Now, I know what you're thinking. You can do the elimination method and you can do the substitution method. So how can it get any harder? By combining simultaneous equations with quadratic equations, of course. Let's have a look at these two. We have two equations, y equals 3x squared and y equals 7x plus 6. Not easy to use the elimination method here, so we'll go for the substitution method. As it happens, this is incredibly easy as the first equation is already in the form y equals. So all we need to do is take the 3x squared term in equation 1 and substitute it for y in the second equation. And this gives 3x squared equals 7x plus 6. Subtracting 7x plus 6 from both sides gives 3x squared, subtract 7x, subtract 6 equals 0, which gives us a simple quadratic that we can factorise into two brackets, 3x plus 2 and x subtract 3, and that's equal to 0, of course. Putting the contents of the first bracket equal to 0 gives 3x plus 2 equals 0, subtract 2 from both sides, 3x equals negative 2, and that tells us that x is negative 2/3. Putting the contents of the second bracket equal to 0 gives x subtract 3 is 0, from which we get x equals 3. Now this is beginning to look as though we're going to get two answers here, as we now have two values of x to put back into the initial equations to calculate corresponding values for y. And so we have, and that shouldn't be too surprising, as one of our equations is a quadratic, and you'll remember that quadratics often give two solutions. First of all, we put x is negative 2/3 into the first equation, y equals 3x squared, and that gives 3 multiplied by negative 2/3 squared. And if you work out those negatives and fractions, that comes to 12/9, which cancels to 4/3. Next, we put x equals 3 into the first equation to get 3 multiplied by 3 squared, which of course is 27. So our two solutions are x equals negative 2/3 and y equals 4/3, and x equals 3 and y is 27. Now this is rather complex and very easy to make a mistake, so we should definitely check the answers by putting them back into the second equation. Putting x equals negative 2/3 into y equals 7x plus 6 gives y equals 7 times negative 2/3 plus 6, which is negative 14/3 plus 6, and changing the 6 into an improper fraction we get negative 14 over 3 plus 18 over 3, and that simplifies to 4 over 3, the answer that we had earlier, so that's encouraging. Now, putting x equals 3 into the second equation too, i.e. y equals 7x plus 6, gives y equals 7 multiplied by 3 plus 6, which of course is 27, and that's what we had before too. So now we can be sure our solutions are correct. Now, one final point to finish with. Sometimes we write the answers as pairs of coordinates like this. Solutions are negative 2/3, 4/3, and 3, 27. Because if we drew the graphs of y equals 3x squared and y equals 7x plus 6, these are the coordinates of the 2 points where the graphs would intersect.